Mathletes, section 3.5 here again, and this time we're going to talk about other trig functions. And we started to actually at the end of the last lesson. Remember, we proved that the derivative of tangent is secant squared, and that the derivative of cotangent is cosecant squared. So now we have a couple new ones. So we have derivative of secant and derivative of cosecant. And actually, these two are going to be, or actually you probably have already done by this point. Those are part of the assignment for the last lesson. And so you'll actually derive those. All right. And so anyway, I wanted to show you as well that on your derivative cheat sheet, we haven't looked at that a whole lot in the videos, but this has a lot of things that we've talked about so far. So it has our limit definition of the derivative. It has some of the notation, right? We talked to, here's Lagrange in a couple different ways. Then we have Leibniz notation. This is one that we haven't talked about a whole lot, and it's not one that I've seen used a whole lot. So yeah, and then here we have at a given point. These are the different ways you can express it. And once again, we've talked about pretty much all of them except for this one, which I haven't seen a whole lot, but still good to recognize in case it comes up. And so yeah, these are some different interpretations: slope of the tangent line, instantaneous rate of change, velocity, right? Those are the three main interpretations of the derivative, or main applications of it. And then we have our main rules here. So we have the sum, the constant rule, right? Constant multiple rule, derivative of a constant, and then we have our product, quotient, and power rule. And then here's the chain rule, which we'll talk about soon. It will be one of the next lessons. And then we have common derivatives. So here's where you'll see all the trig functions. So derivative of sine, cosine, tangent, secant, cosecant, and cotangent, right? So these are the trig functions. All right. So, and then here you'll see this other section here. We'll talk about some of those later on. Maybe not all of them, but we'll talk about inverse functions a little bit, and maybe touch on exponential and log functions, which are over here. All right. So anyway, you can print that paper out. It's two-sided, and this is just 1/4 of it actually. So each side has two of these. It's basically like 4 pages put together into one document, and so it's 2 pages back and front with kind of basically 2 pages on either side. So definitely a good thing to print out and have in your notes, and it's something that you can take with you onto other classes and things like that as you go, and definitely something you can use in this class. Unless we say otherwise on a quiz or a test, it's something that will be available for you to use on a test. It'll be it'll be part of the acceptable resources that you can use. All right, so let's check out this example here. We're finding the equation of a tangent line, and now we're using cotangent, right? So once again, this is stuff we've done before, but now we're doing it with trig functions and these new trig functions that we know. All right, so if you look on your trig cheat sheet, or you look in the book, we know what the derivative of cotangent is, right? So if we're trying to find the equation of a tangent line, then first we have to find the tangent slope, which is equivalent to, and this is at this given point, right? So at x equals pi over 4. And so in order to do that, we have to find the derivative at that point, right? Okay, so first we'll find the derivative of the function. So the derivative of cotangent x, like we proved in the last lesson, is negative cosecant squared x. All right, and so now we just need to find the derivative at pi over 4. So we just plug in pi over 4. All right, and then we can look on our trig chart and find where cosecant equals pi over 4. or where cosecant of what, of pi over 4 equals what is what I should say. All right, so we look at our handy dandy trig chart right here, right? And so we're going to line up cotangent with pi over 4, right? And where we see that they line up or they align is 1, right? And remember that pi over 4 is halfway between 0 and 90. And so that means that the x and y values are the same, which means sine and cosine are the same. And they're both equal to root 2 over 2. So, no, sorry, I made a mistake here. So it's actually, we're looking for cosecant, not cotangent, right? So cotangent at pi over 4 is root 2, right? Remember, cosecant is the reciprocal of sine. And so since sine is root 2 over 2, like I was saying, that means the cosecant would have to be the reciprocal of that, right? So cotangent is 1 at that point, but actually cosecant is pi over 4. And we'll actually need this, so let's hold that thought. And so anyway, when I plug this value in here, instead of cosecant squared of pi over 4, I'm going to put in what cosecant equals, which is root 2. Okay, so it'll be root 2 squared. So that's why the squared is there, because we're squaring cosecant, and then there's still a minus in front. Okay, so when I square a square root, I get what's underneath, and so the answer is negative 2. All right, so that's what our slope of the tangent line is, right? All right, so next, if we're going to write the equation of the line, then we just need, we can use point slope form. And all we need is an x and a y coordinate in addition to the slope. So we have our x coordinate, right? We can call this x1. In order to find y1, we can plug in x1 into the original function. Okay, so what I'm going to do is just find f of, let's do it up here, f of pi over 4. So I'm going to plug in pi over 4 into the original function. So it'll be cotangent of pi over 4. And here's where what we said earlier, that's where the 1 comes in. So that just equals 1. Okay, so our coordinate point is pi over 4 for x and 1 for y. So we can plug in pi over 4 for x. We can plug in 1 for y. And we can plug in negative 2 for slope, for m. So we're going to get y minus 1 equals negative 2 times x minus pi over 4. And that's the equation of our tangent line. All right. So once again, something we've done before, but now we're doing it with trig. So we have to remember some of our trig facts, right, that we learned back in Algebra 2 trig probably, and also, some of our algebra facts in terms of how to find the equation of a line, and then now our new derivative facts as far as how to find derivatives of different trig functions. So a lot went into getting us to this point, right? And shows how far you've come as a mathematician, right? Not every mathematician can do this, just because there's a lot of foundational knowledge you have to know to put it all together and make this happen.